Hello, today we're going to be doing a little demonstration of a distributed system with a node and a client. There is a registry, of course, but since I didn't do anything to modify or change or anything to do with that, I'm just not going to deal with it because it's not really relevant to what I did. All right, so up here you can see we have connected to the node and we are preserving the parameter passing of a message function, even though its use down here has changed somewhat. First of all, we're just going to do a quick echo function. As you can see, it's connected. You can get you get the message here, and you get the message back here. Then we're going to demonstrate right here if the node fails. What happens if we send a message? We have a nice clean message with no error trace. That is thanks to the magic of deadlines, which actually I don't remember being covered in the class. They're here. They'd be a really cool resource to talk about. But anywho, all right. So now we're going to go back and do this again. And while this is spooling up, we're going to talk about, here we have a menu that I designed to be a little more user-friendly. Down here are the options that the user is expected to actually interact with. Here are other services that are found but are not actually interactable. The user wouldn't directly interact with, and on the Slack channel, other student services that are not implemented by my client would appear up here. We'll go over this game mode feature here in just a second. Let's go through converter options. I wasn't really sure how the protocol was written, what was required, whether it was the long form or the short form, so I just supported both. So as you can see here, we can go miles to kilometers, and we got a answer up here. If we want to do it again, we can see we have, let's say if we try and do kilometers to pounds, we get an error message that explains what actually happened, which is very nice. All right, for a library function, we're going to list the books. As you can see, this is the current state of all the books in the library. We're going to do a search books, and we're going to search for the best book on the list, which is The Hobbit. We return just this one. Now we're going to borrow book. This is where things get interesting, and I'll show how this works in the code. I got really tired of typing in the ISBN over and over and over and over. So basically what I did is we will put in a text string. It will submit it as, it'll maintain the protocol. It'll submit it as ISBN first. If that fails, it'll then resubmit it as a search. If that search comes back and only has one result, then we know that we suspect that's the one the user actually wanted. We grab the ISBN, we send a new request, and we actually do return it. That is how Chris is going to borrow The Hobbit without typing in an ISBN. Looking at the list, we can see borrowed by Chris and with a due date. Return actually works exactly the same, but before we do that, we're going to shut down the client. We're going to spool it back up, and we're going to list again to show our state is persistent. Now we're going to return the book because we want our test to actually run properly. Very sad to turn back in The Hobbit, but it's returned, and as you can see, that's been handled properly. Okay, for Haunted House, as you can see, the CLI is getting very cluttered already. We have a lot of things going on, long list. It's not very user-friendly. So what game mode does is a lot of these requests or a lot of these Haunted House options are not actually, they don't actually function. Let me rephrase. So for example, if I say I want to go right here, I'm just going to get error messages. Like there's a set order you typically want to do things. So to streamline that, if you put in game mode, basically every request that we get back from Haunted House will give a game state that will allow the client to identify what options the user should probably select from and present only those options. Obviously, there's a starting point. I should probably also mention set name is required first because the client needs a way of identifying to the server what user to actually get the game data for. So I intercept the player's name and use that in all requests to identify the server whose data actually use. The server will save a file keeping each player's game persistent by just using their first name .json with a little bit of error handling to block people from trying to use like special characters or something. So this used to be a thing with multiple endings. However, that got a little out of hand. So now it's just very simple. Set a name. Now you can see we have the new options as the game state has changed. Reset will wipe the name. We're going to go to start adventure. Now we're in room 1. We have a little background story to what's going on. And then now we're going to explore the ASU Polytechnic campus. Excuse me. I've never actually been to the ASU Polytechnic campus, so if I am uncannily accurate, it's just purely a coincidence. Explore will just repeat the string, like if we want to go and convert some data and come back to this, because we can always toggle game mode off and do our normal thing and then go back to it. Then we might forget like what stage was I at in the game, and you can get this back. Go left and go right basically do the same thing because we don't want to miss any of the story. So now we just increment one room at a time as opposed to going through a maze. So go left and go right basically do the same thing, and reset just sends us back and lets us play over. So I'm just going to go through here. The idea is basically to be a comical reenactment. As you can see here, our UGTA is getting an award because he's so awesome. Here, this is actually part of the story. Here, you're giving a lecture. Here, we have Professor Heinrich's lab has come to life basically because he really likes integrated circuits. Here, we have Professor Acuna's office with his dissertation. Here, this is back to the story, and we're done. Whoops, we have a weird character in here. I did type all this stuff up in Word and then copy paste it over, so that's probably why that is like that. All right, so now we're at the end. We can start over or reset. I'll demonstrate it real quick. So starting over, we go back here, and basically it sets us back to the beginning, but keeps our name. If we want to reset, it'll wipe our name and set us back to the beginning, allowing us to go through the whole thing again. So that is the menu and process, and then we're going to do a quick code overview to go through everything. I'm going to touch on just mostly the client and then highlight like 1 or 2 methods and the protocol for each because we're not going to have enough time to go through much. This is where we intercept and use the haunted, the name for the haunted game. It was first Haunted House, then it was Haunted ASU, and it kind of just morphed back and forth. The stubs are renamed to make a little more sense to me. This is how we're using the deadlines. I'll show an example of that later. Instead of the predefined stuff we had before, now we're running a menu loop, which just jumps right down here. We're going to display a menu and also put the options into a map as a way of mapping integers to strings dynamically each time as the display menu checks the available services again every time it's displayed. This is just handling the input. This is our call to services. All the methods have been redesigned to have their submenus handled within their method. This removes all the parameters and allows us to do this beautiful little gem here. While I'm here, deadlines, we only care about 2 status codes from deadlines. Other than that, we let the normal RPC failure method kick in, so we'll see this in a bunch of places. This is a common failure point, so this is just extracted code as a helper. I won't bother with the rest of it. All right, coming down here, I changed this to registry and node services. It was much easier for me to keep track of that than channel 3 and channel 4. It's just a little easier to read and understand what I was actually doing. Also, there's not really a difference. I just put them in lists. In this case, just to make the code for the menu a little bit easier. The previous methods are all here. They're not used, but they're available since I'm assuming automated testing will require them to be used at some point. Again, here, just this is an example of adding the menus. This is not really interesting. This is the converter. We go in, we make sure things are not empty. Most of the validation is actually being done by the implementation, but here we have a request. At one point in the middle of developing this, I've started making helpers to use requests to clean up the code a little bit. However, that's why sometimes you'll see them actually built out all here, and other times, like I'll call out later, you'll see just like error, and then the methods are passed in, and it's like a helper method that creates it and sends it. It's just a lot easier. list books. This is just getting the list of books. Oh my goodness, right here. Yep, right here, and then creating a formatted string to display them with the return by. Search books. Excuse me. It's basically doing the same thing. We're doing some error checking, and if there are none, we just do the formatting here. Borrow book. This is where I talked about we're going to send the request. Or we're going to send the request. Sorry, that's up here. We're going to get the response, and if it's successful, good to go. But if it's not, then someone might now type in an ISBN. We do a book search, book search up here. Get the response. If it's successful and we found only one entry, this is the get the ISBN. This is the what we described and I went through in the actual demonstration itself. And return books is exactly the same thing. Almost all of these are pretty generic and just send the information to the implementation. This is the menu that requests the name. It actually builds it and sends back. In every single message, when we get the response, we update the game state just to make sure we're showing the most accurate information possible. This is what happens if you put in a name with a save existing. It just for user kind of make things look clear. It says loads last save game. Under the hood, that's a resume or start over. The start over, this is so you're already in the same room, so it doesn't change your room or anything. It just overwrites the old save with the new save, and we'll show that in the implementation. Resume. These are all just, there's no parameters, so these are just messages and they're sent off, and they all have the this is what I was showing you before for the deadlines thing, looking for the status codes for unavailable or disconnect. All of these are just, so the only one really with parameters is the set name. After that, it's mostly just automated parameters are set. These both switch to move. This is the menu. The menu just goes based on game mode and game state. Game is for game mode. Supported is for non-game mode. And down here we have, where is unsupported here? No, unsupported. I'm blind. Sorry, right here. Unsupported right here. And this goes in the top. However, the top is just omitted in game mode here, where we print out just the bottom. And this handles all that. This just cleans up this string and makes it all nice and pretty. And then we saw all this. Converter implementation is almost identical to the code I made for assignment 3, I think it was. It was done in JSON. But this is basically just putting the buckets, make it easy to find out if both the to and the from is in the same bucket, using the same strategy as before. We are reducing everything to a base unit and then going back up to the individual unit. It's just the cleanest way I can think of to do this. Divide by, so we go to feet and we go to kilograms as the initial, and then we divide by these values to get these values, and you'll see that down below. All right, so if they're empty, obviously we return. This is where we do more robust error handling. If they're the exact same unit, like if we're converting miles to miles, we just blindly pass the result through. We don't have to process anything, and we call it a day. This we're going to use to determine if everything is, or if both the from and the to are from the same category. And you can see that logic right here. We handle that here. We do the math. We send the response. Weight is exactly the same. Excuse me, I don't know why I was, all right. Temperature is just a little different because we were checking for absolute value. We have those two checks here. Otherwise, we have the formulas here. You'll never actually, anytime you see unexpected state, it's like, I can't imagine why you'd see this, but it was just here for safety. Here's an example. Actually, is there anything else? There's nothing else really worth talking. That's rounding. Okay. This is an example of what I was talking about before with the helper that I started making. Is we just take the parameters here and that was the wrong. All right. And then we send in the parameters, and this is just a helper to clean up the code a little bit. We'll do haunted last. Library implementation is a 2-part solution. We are not doing good on time. Okay. This is basically what's provided. This is the save data. This is sort of just a helper. We're going to use this to be able to use a get ISBN as opposed to having to do an enhanced for loop every time. Joke's on me though, there's an enhanced for loop in the very first thing right here. These are all kind of self-explanatory. We're just looking through the collection and updating the information. The main purpose of this class is to extract data from the library implementation. The main selling point, or the main point that makes this file worthwhile, is we see if a save file exists. If it does, we read that. Otherwise, we do the initial. We immediately save it to create a save file. That way we can store the borrowed status moving forward. This is synchronized. All of these are synchronized. The only ones that are not are these, because these are called from inside a synchronized method. So the whole thing is pretty safe there. Library implementation. I'm just gonna pick. There's nothing remotely exciting in this. I'm just gonna pick one. As you can see, we have early validate. We have validation, and more validation. We get the book. Then we do, you guessed it, more validation down here. And then finally, if everything's good, we return a response. The whole thing is basically the same. Haunted house, as I mentioned before, because there's only parameters in the get name, we have two helpers up here. So this should be a JSON, but I ran out of time and got lazy, to be perfectly honest. We use an object as a file lock here. We don't have it synchronized on a specific object, so I'll briefly show you this at the very bottom. These are the helpers. At this point, I had figured out both helpers, and I was sending in a lot of data, so it just made sense, because this times 50 throughout the class would just get ridiculous. We're sending the game state along with all the rest of the protocol with every single message, just to make sure the client stays in sync, because there's a lot of interaction that's actually required. A lot of just pick something. Starting over, this is the one where we retain the name and just reset the room back to 0. Whereas something like resume, this is where you're pulling up a save game. So we load it and we go with that. Reset is where we wipe the name and reset to 0 so we can insert a new name. Start adventure. These are just, they send oh, this is worth mentioning. This is the explore, and so we send the room as you'd expect. However, when we move, I didn't want to create a second protocol call, so we just automatically kind of do Explore's job. I don't know if that's kind of a protocol violation, but it does save on calls, and when you go to a new room, it's kind of assumed you want to look around immediately. I didn't want to make the user have to call Explore every single time. Previously, we had a randomized system for moving about. However, that got removed. Synchronize, I went through here and really tried to make sure the minimum amount was synchronized. So file access goes through the file lock. Everything else is kind of left alone. I wasn't able to break it in my testing, and this is the game state calculation. All right, I think we briefly covered everything, so I'm going to move that over here. I'm going to shut this down, restart this real quick, because we need a full joke list that's running. As you can see, the server, I'm going to run a quick test suite. We have all the tests that were previously in here, plus we have the happy and sad paths for library and converter per the instructions. If you're still watching this, I'm very impressed. Thank you very much for watching, and have a wonderful day. Bye.